Hello everyone, welcome to the video lecture series on basics of electrical engineering, and again we are going to deal in this video also with the course outcome 1, that is to solve DC electric circuits using fundamental laws of electric and magnetic circuits and also the star delta transformation. In the previous video, we had gone through the mesh matrix method. I hope this method was clear for everyone, and these are the problems that we had discussed. We had discussed two problems. Any particular circuit you can solve using this mesh matrix method, and this was a problem that I had given for a practice session. Hope all of you have completed this particular problem and found out the value of I1. In this video, we are going to deal mainly with the node matrix method. Now, in the node matrix method, what we are going to do is that we are going to simply write down the node equations in the usual manner and convert it into the matrix form. Okay, so there is another method to do the node matrix method, but this is the method that this is the procedure that we are going to follow. Okay, it is to make the process more easier. Okay, so here we can just go directly onto a problem. We have to calculate the node voltages in the circuit shown below. So first and foremost, we can see that in the problem they have already marked the node voltages V1 and V2, and there is also a ground present over here, and we are going to write down the node equations in the normal manner. So I'm going to write down the node 1 equation. Okay, that is I'm going to apply KCL. So before that, we can just mark the current directions. So I'm just marking the currents in a direction that I like. I'm just taking my preferred directions, I1, and I'm going to take this as I2, and this direction will be the same. And I'm going to take I3 in the downward direction, and you have a current source over here. So I'm going to write the equation for node 1. We are following the same procedure as that for node analysis. So here you can see when you are writing the equations, it's going to be the number of incoming currents is simply the 5 ampere. So 5 is equal to the outgoing sum of the outgoing current. So you can see over here I1 and I2 both are outgoing. So I'm just going to give this an equation number, and similarly I'm going to write the node 2 equation. So the currents that are entering, you can see over here I2 is entering as well as the 10 ampere is also entering. So I can write I2 plus 10 is equal to the sum of outgoing current. So you can see here 5 is outgoing and I3 is also outgoing. So 5 plus I3. Right. And I'm just going to rearrange this. So I will get it as I2 minus I2 minus I3 is equal to minus 5. So this will be my second equation. Next I am going to write down the current equations. Next I am going to write down the current equations. So we can just find out I1, I2, I3. Okay, so I1, you can see over here I1 is starting from V1 and it is ending at the ground. There are no voltage sources present in between. It's starting from V1 and ending at the ground. So it will be V1 minus 0 divided by 2. Or I can say it is V1 by 2. Next you have I2. Next you have I2. I2 is starting from V1 and it is ending at V2. So I can write I2 is equal to V1 minus V2 divided by 4. Then finally I am just going to find out I3. I am just going to write it over here. I3 is equal to, it is starting from V2 and ending at 0. So it is going to be V2 minus 0 divided by 6. And you can substitute these values. You can substitute I1 and I2 in the first equation and you will get a equation in terms of V1 and V2. Similarly, you can substitute I2 and I3 in the second equation and you can get another equation. Okay, so I'm just going to substitute it over here. So it will be V1 by 2 plus V1 minus V2 by 4. That will be equal to 5. So on rearranging, I'm going to get the equation as I'm not going to write the steps over here. You can rearrange it on your own and you are going to get the equation 3V1 minus V2 is equal to 20, and I'm going to give this as an equation number 3. So on substituting in the first equation, this is what I have got, and I'm similarly going to substitute in the second equation the current equations. So you are going to get it as V1 minus V2 divided by 4 minus V2 by 6 is equal to minus 5. And on solving, I'm not going to solve it over here. You can solve it on your own and you will get an equation. 3V1 plus 5V2 is equal to 60. And this is going to be my equation number 4. So you can see over here, this is the equation. You are having V1, V2 is equal to a constant. V1, V2 is equal to a constant. So the equation 3 and equation 4, they are having a similar pattern. V1, V2 is equal to a constant. V1, V2 is equal to a constant. So this equation, I can write it in the matrix form. Okay, this equation I can write it in the matrix form. So how am I going to write it in the matrix form? Okay, so here you can see there are only V1, V2. So I am going to write V1 and V2 as a column matrix. V1, V2. That is equal to, I think it will be easier if I just write these equations one below the other. Right, so I'm just making it in an easier manner. So after solving this equation, I have written it over here. Now you see over here there is V1, V2 that is equal to constant. So what I'm going to do, I'm going to write it in the matrix form. So you are having V1, V2 is equal to, see, on the RHS of the equal to sign, you are having 20 and 60. The 20 and 60, I'm going to write it like this. Okay. So I have written V1 and V2 as a column matrix, and the terms on the RHS of the two equations, I have written it in an orderly manner, 20 and then 60. Similarly, I am going to have a square matrix also over here. And the values of the square matrices are going to be the coefficients of V1 and V2. Okay, so the first term is going to be the first element or the first coefficient of V1. So here I can write the coefficient of V1 is 3. Now, the next coefficient, that is the coefficient of V2, that is over here you can see the next term is V2 and that will be minus 1. Then here you are having the next term is minus 3 and the next term over here is 5. Okay, so you just write down in an orderly manner 3, minus 1, minus 3 and 5. But please make sure that the values are in the proper order. First V1, then V2. V1, V2 is equal to a constant. V1, V2 is equal to a constant. Please make sure that you are following this procedure before you fill out the matrix, and we need to find out the values of V1 and V2. So again here we are simply going to use the Cramer's rule. Okay, so I hope all of you are already familiar with the Cramer's rule. For finding out V1, you have to find out delta 1 divided by delta. Delta is simply the determinant of this whole matrix, that is 3 minus 1 minus 3 and 5, and delta 1 is the delta 1 is simply the determinant of a different matrix. And how can you find out the matrix delta 1? Okay, so you need to find out V1. So you replace the first column with the column matrix and you leave the remaining matrices as it is. So you have 3 and minus 3 will be replaced by 20 and 60, and the remaining columns are not going to be changed. You find out the determinant, you will get V1, and similarly you can find out V2. V2 will be delta 2 divided by delta. How can you find out delta? Delta will be the same denominator. You find the determinant of 3, minus 1, minus 3 and 5. To find out delta 2, you replace the second column with the column matrix. You replace the second column with the column matrix, as the remaining columns will be same. So 3 minus 3 is not changed, and instead of minus 1 and 5 you keep place 20 and 60 and you find out the value of V1 and V2. Now in the similar manner you can just do this particular problem. In this particular problem also you can see that there are only two nodes. You have V1 and V2 and you find out the currents in the various branches. I want you to do this as a practice problem. If you have any doubts, you can always feel free to ask me, or you can just comment in the comment section below. Okay, so thank you. I hope the video was useful. Thank you everyone.